See, good afternoon, students. Today we are going to discuss a DT-based topic on groundings and methods of groundings. So, before going to the topic, shall we discuss why grounding is needed? Can anyone say why grounding is needed? Mike.
Grounding and methods of grounding power systems protect and switch gears. Design thinking approach empathy, define, ideate, prototype, and test implement. Ensure electrical safety and system stability. Essential part of protection and switchgear systems. Prevent equipment damage, improve reliability of power system used in a subscription generator and transformer.
Okay. So, can anyone empathize about this grounding? Empathize this grounding and methods of grounding.
Shall we?
Yes.
Need for grounding empathize stage. Limits over voltage due to the lightning. Ensure a fast fault detection. Stability system voltage. Reduce shock horizon. Minimize equipment damage. Example transformer nature grounding.
Us. Okay. Yes. Uh, so, who's going to define this topic? Why it is? Why grounding is needed? Who's going to define? Yes. Who's going to define?
Yeah, already Sri said about that. Why grounding is needed to ensure the system safety, stabilities, and to prevent from the over voltage. And there is some types of grounding are there. What are there are resistance grounding, reactance grounding, resonant grounding, underground systems, and used based on voltage levels and applications.
Okay. Define. Define. So, any ideate about this grounding? Next stage is ideate. Who's going to ideate?
In the ideate stage, we are going to see in a neutral directly connected to earth, and then the high ground fault current for the fast relay operation and simple and economical. So we are using a in LV system, example in a 415-volt industrial systems.
So, what about ideate part? Do you have any other ideate part?
So in the stage of an ideate, we can see about the neutral connected to the resistor and the limit fault currents to reduces the arc flash risk, high and the low resistant types, protects the generators. For example, generator with NGR.
Any other ideate type?
Reactance grounding. Neutral grounded through reactor controls the fault current used in a MV system, suitable for high capacitive system, economically for high power systems. Examples: substation transfer grounding.
Okay. Do you have any other ideate or prototype? How we are going to solve this problem by using ideate or prototype? Who's going to discuss? Yourself.
In a prototype stage, use Peterson coil, cancels the capacity fault current, reduce arc grounding fault, uh, improve service continuous, used to distribution system. Example, rural distribution network.
Okay. So how we are going to implement by designing part? So anyone is ready to tell about the designing or implement part?
The another left out prototype stage is underground systems. In that, no international no intentional neutral grounding, very small fault current, continuous operation during first off, and difficult fault detection, and high over voltage risk. For example, we take it as old industry plants where that the components were old and rusted. Yeah.
So any prototype or any design part we are going to discuss in prototype.
We're going to see about the equipment grounding products from humans. So the system grounding stabilizes the system. So equipment body connected to the earth, so the neutral connected to earth. It can be essential for protection coordination. So for the example, motor body versus transformer neutral grounding.
Okay. So some other any discussion about the designing or what are difference?
So by testing it, the grounding in the production, it enables the earth fault relay operations. It improves the selectivity and it limits the transient over voltage. It supports the overcurrent production and it improves the reliability. For example, we can see with the SLG fault trip operation.
So any comparison between the earthing and grounding? Can anyone say about comparison between?
Then we can implement the stages: soil residue testing, steps steps and touch potential limits, ground resistance less than 1 ohm. Next day, electrode selections. Next day, periodic maintaining records.
So these are the two. Okay. So finally, we are going to summarize this. So what? Who's going to summarize this? Any volunteers?
Yeah, here we saw about the grounding and how it was implemented in these power systems, and now we are going to see the summary of that. Grounding ensures safety and system stability, and different methods suits different systems. Solid grounding for a high fault current, resistance reactance grounding for a controlled current, and resonant grounding for arc suppressions. And proper design improves.
Okay, I hope now you understood about grounding and sit down. Grounding and methods of grounding. So why grounding is needed and how the groundings, what are the types of grounding and design wise how it is implemented for various applications. And we'll meet in next class. Thank you. Thank you so much.